we're going to be answering the question, are 4 valves per cylinder better than 2 valves per cylinder? Now, there are many different reasons for choosing one option over the other, but I'm going to be focusing on which allows for more airflow, as this is the primary purpose of valves. We'll have 2 examples, both using a cylinder with a bore of 80 millimeters. Everything in this video will be drawn to scale. The first cylinder will have 4 valves, with 2 intake valves shown in blue, which are slightly larger than the exhaust valves shown in red. The second cylinder will have 2 valves, with the intake valve slightly larger than the exhaust valve, representative of an overhead valve engine. It's worth mentioning that I've included larger gaps between the valves in the 4-valve cylinder to help further illustrate a point, while the 2-valve cylinder has smaller gaps to maximize the useful area of the valves. Also important to understand is that this example assumes the cylinder head is flat, which is not the case, and thus slightly larger valves could be used, though this is true for both designs. So for the cylinder on the left, the intake valves have a diameter of 30 millimeters. The exhaust valves have a diameter of 25 millimeters. Our question is, what is the useful area that the valves of this size can provide? To better understand this, let's look at a side view of the cylinder. On the left, we have a closed intake valve. On the right, we have an intake valve fully open with 5 millimeters of lift. The useful area for which air can pass from the intake manifold into the cylinder is equal to the cross-sectional area of the circumference of the intake valve when it is fully open. In this case, it's a cylinder of radius 30 millimeters with a height of 5 millimeters. This is the open space for which air can flow into the cylinder. Finding the area is as simple as multiplying the circumference of the cylinder by its height. Therefore, the area is equal to pi times the diameter of the valves times the amount of valve lift. In other words, A equals pi dH. So for our first example, the area for airflow of the 4-valve cylinder is equal to 2 times pi dH, since there are 2 intake valves. 2 times pi times 30 times 5 gives an area of 300 pi square millimeters. Now let's compare to the cylinder with 2 valves per cylinder. The intake valve has a diameter of 43 millimeters, while the exhaust valve has a diameter of 30 millimeters. To calculate the intake valve cross-sectional area, we use our same equation pi dH. This gives us pi times 43 times 5, assuming the same amount of valve lift as the 4-valve cylinder, giving us an area of 215 pi square millimeters. 300 is obviously larger than 215, so in this case the 4-valve cylinder has 40% more area for flow, which can make a significant difference in top-end power. In order for the 2-valve cylinder to have relatively the same intake area, it would require 7 millimeters of lift, though of course with increased lift, you start to run into clearance issues with the pistons. All variables equal, having 4 valves provides significantly greater airflow. Now let's look at the exhaust valves. With 2 exhaust valves, the area is equal to 2 pi times 25 times 5, or 250 pi square millimeters. For the 2-valve scenario, however, the exhaust valve area is equal to pi times 30 times 5, or 150 pi square millimeters. In other words, dual exhaust valves provide 67% more area, which means the overhead valve setup would require about 8.3 millimeters of lift to provide an equal claim. Thus, for both intake and exhaust valves, having 4 valves per cylinder will allow for more airflow than using just 2 valves, assuming all other variables are held equal. Thank you for watching. If you have any questions or comments, feel free to leave them below.